let me get my camera aligned here, and I'll just put my view screen up so I can see if I'm in frame. Am I going to be in frame? No. This is going to be a tricky one. I might actually have to zoom this back a little bit. Let's see here. Pretty good. Yeah, that's good. I'm in frame. Cool. Let us get started. I'm going to grab something to sit on, I think, and maybe I'll just put this on the floor. How would you like that? Here we go. All right, ladies and germs, let's check this guy out. So this is an airFiber 5X HD. Today, we are going to tear it down. That is what we're going to do. So I'm going to show you guys how to take these apart. Now, you're going to need a very long Phillips bit. You're going to need a 13 mil socket or a 1/2 inch. And you're going to need something very small for pulling out, taking out plugs. You're also going to need a bowl. And inside of that bowl, you should probably have a magnet. So I'm gonna go and get a magnet from my fridge, if I can get it off. Here we go. Good, the bowl's stainless. That makes things easier. Okay, so let's do this. First things first, I'm gonna take this GPS antenna. Wow, that zip tie just crumbled. All right, so on the back here, good, I can see the screen. This is kind of a pop teardown video, by the way, so I should actually have a view screen connected to this camera so I can actually see much bigger. Let's see here. Of course they tighten that up with a wrench. You don't have to tighten these things up with a wrench, just so that you know. It's not really good because you can actually break the SMA connector. They're not designed for torque. So you're actually putting torque against the main board here. All right, so first I'm gonna take off this little GPS antenna here. Now make a note, because I'm gonna show you the difference between the HD board and the regular airFiber 24. So there we go. Take this, I'll put this aside. Let's put this over here. All right, let's get these guys off now. Look at how long that is. Oh. Hey, that stud actually came right out. That's kind of handy because the other one went right in, so now I can, hey, that was a cool little fortunate thing for me. There's a few parts to this assembly, by the way, because you've got actually this, you've got the nylock, which is the 13 mil nut, and then there is a washer, or actually there's a little, I'll show you, don't worry here. Here we go. So this little guy here inserts into the vibration mount, this rubber isolator that actually connects the cradle to the chassis. For that reason, the cradle itself is not actually grounded. It's not bonded to the radio. It's actually fairly isolated electrically from the tower itself. That's why it's critical to use the grounding lug when you have these things. Because if you don't, your shit's probably gonna go poof. You don't fucking want that now, do you? Here we go. All right, whatever. Okay, so we've got the cradle free. I'm just gonna take these last inserts out. Not exactly sure what those are called. I think they're called cap stands, or maybe just insert. Here we go, so we're gonna put this one aside now. So what this is going to do for us, and by the way, it's kind of interesting that these guys are actually studs on here. I didn't realize that they're actually studs, but I guess that's what happens when they get rusted. So now I'm gonna take this cap, and I'm actually gonna use a dentist pick. And I'm gonna get in here, and I'm just gonna pick it out. See here. I usually use a much more aggressive approach, but I wanted to do it the right way. So, seeing as I've got to pick the little bastards out, this is supposed to keep water out of the screw hole, the well, the recess, the socket, the hole. This putty knife seems to work pretty good. Here we go. It's 1, 2. There's a lot of screws involved in this operation, by the way, I should warn you. I'm probably going to do half of this on the floor here and the other half on the bench, just so that you know. There we go. Let's get in here. I'm going to try not to wreck these plastic plugs, because, you know, aesthetics are one thing. I mean, even if this thing is covered in bird shit and, you know, sitting up on a tower, you do want it to look good. This one's actually kind of buried, so I'm just going to use this repulsively sharp knife. You can get underneath it now and work it out. And by the way, some of these plugs will stick, so don't get upset if they do. It's just, they're very tight fitting. And if you ever lose them, do not put silicone in the hole. Honestly, I don't think that it'll really hurt anything if the plugs aren't in there, because they're not necessarily watertight. If you look at them, you'll see what I mean. But if you really want to seal them up, you can use putty. So you can actually use like mastic putty, I think it's called. There we we go. So now I've got my bit here, my Phillips. All right, there we go. It might be a little bit tight for this one here, but this will get into most of them. Now I've got another tool specifically for getting into the really tight ones here, and that's my IKEA L wrench. Fits into the hole just perfectly, don't it? Isn't it nice when it fits nice and snug into the hole? You know, not too tight, not too loose, just right. Okay. All right, so I know that these guys here are both very deep. So we're going deep with the tip of our screwdriver here. Oh, and on a side note, I have been picked on a lot lately because people all say that I'm a dude. And it's like, no, I'm actually not a dude, believe it or not. I know, it's really easy to tell that I'm not a dude. But yeah, I'm actually not a dude. There you go. The name Sarah should give it away. Let's see here. So that's those 4 deep ones done. Let's take that out now. By the way, is there some rule that says that if you're female that you have to wear stupid fucking frilly shit and you're obligated to bear children and shit? I don't think there is. I don't think there's really any rules about that. There we go. So now here's the scary part. You have to be very, very, very careful because there's actually long feed horns or waveguides, feed horns, whatever, that protrude down into the actual dishes here, okay? So you gotta be very, very careful when you clear the seal here, when you finally break the seal open. There we go. Very, very careful about this. There we go. This comes straight out like that. Whoops, there's my screws. Now the reason why you have to be careful is because these guys can come off very easy. Now, in a lot of cases when you take these guys out, the horns are put together very well, they're strong. But we have actually seen ones of these that have been in operation for a while, where the actual guides and elements will come out easily because after they've been in operation for so long, the glue cures and it comes apart. So I have been kind of torn on whether to continue using epoxy or to actually use silicone, because these are precise. this is millimeter wave, so when these things go in, they have to go in very, very carefully. And even more so, you have to be careful, is that the inside of these is actually a very, very shiny surface. If you go back to my airFiber 5 teardown, I think I did an AF34 Classic teardown, you'll see what I mean. It's a mirror polish surface on the inside, so we really don't want to get any scratches in it. So now, unfortunately, the transmitting antenna, the element, the tip, has just fallen off inside of this radio, inside of this antenna, this, what do you call this, reflector? So I'm gonna very, very carefully grab a couple more of these screws, by the way. That's a goof on my behalf. I'm a little nervous doing this, by the way. I'm getting some criticism lately. So what's all in here? So I'm gonna slowly rotate this. There we go. So by slowly rotating this, I avoided any like slams and scratches and whatnot. So now this is literally just a great big antenna. So what this is basically passive, the rest of this. So this is a polished aluminum surface on the inside of both of these. They look like mirrors, okay? Okay. So you've got the receiving antenna and you've got the transmit antenna. The receiving antenna is much bigger because it's collecting all the energy, whereas this one here can actually focus over distance, okay? Okay. That's why there's a difference, but look at this guy here. So the epoxy cures and it's no good over time. So with a lot of these guys, when people send them to us, we actually have to glue these back on. So when I hand this unit over to Thomas, I'm gonna let him know that this piece came off and I'm gonna let him refasten that because he has a special way of doing these things to make sure that there's no issues with the alignment within the actual reflector, okay? Okay. So I'm gonna put this aside now. I'm also not used to working sitting on the floor like this, so I do apologize. This is outside of my normal realm, but and by the way, this is going to sound like I'm throwing somebody under the bus, but no, actually Thomas specifically wanted me to do a video on teardowns of these because when you guys are sending us equipment for repair, to ship us a giant radio like this, when the only thing you need to send us for repair is this board and the horns, makes no sense to us. I mean, like, think about that. You can reduce your shipping costs by sending us just the circuit board, right? And because like this is bulky, it's going to take up room. And this is heavy, as is this. The circuit board weighs nothing. I should actually do a comparison in parts to what it weighs before and after, and you'll see what I mean, because this tiny little board, we had somebody send us a box of airFibers to repair, and they sent us 16 airFibers in a small package. We sent them all back, every airFiber was working. We had one company send us about a few dozen of them, and actually we managed to fix most of them, but they came from a very bad storm zone, so there was a lot of damage.
That's a lot of damage!
Anyway, I digress. Here is the actual radio heatsink. As you can see, it's a big chunky heatsink with a lot of thermal mass, and the actual boards themselves. And these are our elements and waveguides. So you can see here that this is actually hollow tube going down into here, and these are the, what do they call them? There's a term for it. They're the RF chambers, the tuning chambers, okay? It's basically the bandpass section and wave propagation where I guess it's mixed inside of there. I'm actually afraid to put this in here because I need to find it. I think it goes in just like this if I'm looking at the way the epoxy's on there. There we go. So now, I think I got one more screw. There we go. That's the last screw, I think. All right, so now we're gonna take this over to the workbench and I'll continue the teardown, because in that way, well, you know what? Then I've got to do another setup. I'll continue the teardown very carefully on the floor here, and then I can move this over to the bench. So now that we're doing this, let me move the camera just a wee bit closer, because who cares if you can see my hideous face? Because personally, I don't. There we go. And now I will simply point the camera and lock it in place, and then there we go. We have, there it is, and I should be able to see myself now. So now, what I am going to do, I'm actually gonna grab this little crate, because then I don't have to go and sit up on my workbench, because realistically, this is a radio that got blown up in a thunderstorm, so yeah, it's gonna get fixed, but if you guys have ever seen field repairs, you'd understand what I'm talking about. All right, so now, this part here is the important part. You have to be very, very careful with this. And I'm gonna show you right now, actually. I'll go and get the AF24 Classic. This is an AF24 Classic board. You'll see one of the big differences here is that the GPS antenna for the 24 Classic is on board, whereas the antenna, the GPS antenna here is actually brought out externally through this tail to the external antenna. But if you take a close look, you're gonna notice that these boards are nearly identical. In fact, when I get this thing out of here, I'll be forced to do the top-down aspect of it because, of course, we will need to look at these closer on the workbench in the top-down mode, but you'll be able to see that there's really not a lot of difference between these two. All right, put that aside here. I'm gonna get a screwdriver, and I'm gonna very kid glove-ish. And by the way, that term, kid gloves, I'm gonna handle this with kid gloves. That kind of doesn't make sense. What child have you seen has a delicate touch? I haven't seen any. And you know what, before I continue this, let me actually grab a second dish. I've got another little dish here, and I'm actually going to put the screws into it. So I'm gonna take my first screw, in you go. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Oh shit,
hold on.
Here we go again.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 screws on each of these plates. Now, we can take these out with a drill. I'm just going to be very careful at how I do it though. Yeah, I don't like that. I'm getting filings on here. Being very, very delicate, very ginger right now, by the way. So these ones you can get access to very, very easily. All those guys there. This one here, I'm gonna have to fold these little butterflies here. There we go. So I'm now gonna lift all of these screws. 1, 2, 3, 4, 5. Are you guys starting to see now why my business partner actually does all the repairs? I'm great with DC plant stuff and power equipment, and yeah, I do repairs when we have overflow, but you know, I'm a big hulking ape, so I prefer to stick to doing power electronics and RF and all that stuff. And by the way, you're probably noticing now that there's 4 screws that I haven't gotten to, which are right around where the waveguide enters into the chambers here. You're gonna see why in a second. These guys here, it's very difficult to get into them with the actual ground plane here, so you have to be very, very careful with these ones, because you don't want to damage any of these. This actually seals into here. That seals into the socket there to complete the chamber. So I'm very carefully going in on an angle, and I'm applying a bit of pressure to break the seal. You got to be very careful that you push firmly but not too hard, because you do not want to damage the head. I'm going to switch to a slot screwdriver, by the way, a very fine one that I can get in at a better angle. These are little tricks. Say slots are kind of a universal in a way, but again, be very careful not to jump the socket. If you jump the little sockets, a little crisscrossy on the Phillips here, you will damage the screw and introduce filings into the board. And these screws are critical for this thing to work properly. So that's out. So now there's thermal paste holding these guys on. See? So you can see that, and you can see a little waveguide here. Isn't that neat?
Okay. That's neat.
So you can actually see the RF passages, the RF pathways. You can see where the actual traces, the elements follow inside of their little walkways, their little halls. Okay, so I'm gonna take this guy here and I'm gonna put it aside for the second, and I actually forgot that I needed some Ziploc bags. It's been a long time since I've worked on an airFiber 24 because that's Thomas's full-time gig. He focuses on this stuff. It's his area of expertise. We've got a very nice clean room lab upstairs that we work with. I'm gonna put this one in here. When you're working with this stuff, you have to be very, very careful with it, by the way. I'm gonna take my screws as well, and put them into a bag. We'll have more screws in a minute, so I'll leave that one alone. Okay, so now this guy. Let's do this one now. This one's a little bit trickier, because like it does have those holes to get in with, but it's still very tricky to get into them. I think that's the most I can do with this screw gun. Oh, I got two right here. Now also, you know what's really interesting? I can't show you all the tools that we have in the lab, but the Phillips driver that we use is actually on a cable, and it's actually like specifically for Phillips bits. That's it. And it's like basically it just hangs there. You grab it and you go in, and it's got a small motor pack on it. It's pretty cool actually. It's basically a corded Phillips electric screwdriver, but it's designed to be in a clean area, and it's also designed specifically for this use, so it's also ESD protected. Not that we really need to worry about ESD here right now. I keep the air actually very, very humid in the house here. Semi-important actually in the wintertime because it gets so dry. You don't want to go tick and discharge. Although I guess in this case here, it's not going to do much, but okay, now we can go in with a slot screwdriver. This is the tricky part. See how I'm going in? So you don't want to damage the waveguide here. There's one, here's two. See how tricky it is? So if you do jump a socket like I just did, it's not the end of the world, just as long as you don't break off little pieces of the top of the Phillips bit, just because it'll happen when you're doing tight spots like this. I'm kind of reading to you as I go, like a play-by-play, I guess is what you guys would be calling it. And actually, I can see a couple of QC issues here. So, I mean, like, I'm going to point them out for you as well so you can see that though we have to be very careful with this stuff and it's precision materials, it's still not entirely perfect. Okay, there we go. I've got all of them. So I'm going to grab my little baggie here, going in on an angle. By the way, you can get these tweezer sets on eBay very cheap, Amazon or whatever. Okay, so now, same thing. Pops off. This is the, look at all the little pathways here. Isn't that neat? So you can see like capacitive couplings here. Neat, eh?
That's neat.
Now, I may be smart and I know a lot of stuff, but I'm not an expert on everything. I'm not. This is somebody actually said, oh yeah, you know everything. No, I don't. This would be something for Tassos from RF Elements to explain, is how these little guys here. He'd probably be good for that. Or one of the guys from ALGcom, or maybe a Ubiquiti guy can step up and see exactly what's going on here. This is where a ham radio operator would probably know what's going on here, but these are basically little capacitive bridges, as far as I know. And they have their own little cavities here as well, that everything happens in. It's kind of neat. So if we look here, that's going to be right there. So they happen in these little tunnels here that go between the different elements here, the mixing aspects and the radio, the RF stuffs. Because like you've got your radios, and you've got multiplexers and demultiplexers, and yeah, it's really cool switching stuff. And of course, all of this stuff has to be high speed. It switches at high speed because it's such a high frequency device. This guy here is very big, so I'm going to carefully put this in here. And of course, if you're shipping these things to us, make sure to pack them carefully because sometimes they fall apart in the mail, no matter how well packed they are. And it's not entirely your fault. Sorry, it's not necessarily your fault. Sorry. It's like I showed you, these guys, the epoxy cures on them, and then they just easily come apart. And sometimes the ceramic on here will just crack all together and fall off. We've actually had to repair the ceramics on these guys on occasion. Oh, and before I put this away, you can actually see that in the milling here, there's actually some flaw in this. There's actually damage to this. And this is actually manufacturing damage. So if I, there we go, I can actually pick it off. So when this was formed or cast, it looks like there was a little fracture on the surface of this, or when they were installing this, that somebody dinged the side of it or caught a screwdriver on it. So in manufacturing, there's actually a tiny little piece of metal on here, which, you know, given the right conditions, hot, cold, hot, cold, hot, cold, could potentially break free, land on the board, and cause a short. So sometimes that happens with equipment because nothing's perfect. And when you're getting a deal on equipment at the prices that you guys are used to paying, You have to remember that. That's actually very cost effective, okay? So now, let me see here. Do I have a wrench of that size? No, I don't. So, rather than be an idiot, there's nothing wrong with using a pair of duckbill pliers, but I do have a little tiny adjustable here. Just ripped my pants. I think I did. I'm gonna crack this carefully. Very, very carefully. There we go. And this is probably an SMA. Yeah, it's large SMA. There we go. So now, there's the board. Grab that other board and I'll do a side-by-side comparison once again. So as you can see, they are nearly identical, except this ROM here has AF2008. This one has, 24008, 24009. There's your 100 meg magnetic. There's your gigabit magnetic, your chain. They're nearly identical, aren't they? 58A, SK8W, 59A, 593W, G1. So these actually have different APUs in them. And then these are the Invictus chips, I'm sure. So these are Defiant 24Gs. Put this one right here. It is fine because that's all ground plane on there. By the way, to my editor, blur that out for me, please. Thanks, guys. I wouldn't be entrusted with hardware if I wasn't careful with it, and I didn't do a very careful job. And just an FYI for some of you guys out there that will shit talk me and say, "Ow, how dare you don't do that in a clean lab environment." Have you ever done field repairs? Because I have. I've had to go to tower sites, drop shit to the ground, and rework it in the back of a truck or on the hood of a truck or on the flatbed of a truck. Trust me, okay? That sort of shit happens. You can do it very carefully. All right, so I'm going to very carefully lift this out. So I'm going to get a little grip on the transformer because the transformer actually has a very, very good anchor point. I'm just going to wiggle it a little bit to get it loose. There's pins here. There we go, and this should just pop out. Just one more pin, we're free. So I've now wiggled this thing loose because there's 4 anchor pins, 1, 2, 3, 4. Okay, now this here, I should just be able to pop it off. Yep, that pops off. There is the board. This is basically what you need to ship us. So if you're sending stuff to us for repairs through the ISP technology page, and normally I don't plug our site, but I've been asked to make this video by Thomas, who runs the lab, because he says that he needs to be able to show people how to take these things apart. So this is a two-purpose video, okay? So if you're sending us these, we need these pieces here, the 2 waveguides, okay? And we need the circuit board. Now when you pack these things, be careful. Thomas will actually tell you how he wants these packed after he consults with you about how to send these to us. Because he's got a very particular method at how these things should be shipped to us, depending on how many are coming to us at a time, okay? So now if we flip it over here, you'll see where things marry up. So if we look here, you'll see that there's a couple of knurled out little spots here for the transformer pins, because you can see now how I was telling you about how strong the transformer is. This upper magnetic ring has epoxy injection on the top and bottom of the transformer to anchor it. So though I'm not saying grab that and yank on it, it's actually fairly well secured to the board, so that's a very strong anchor point that you can draw from, as are the ports to a degree. Again, I'm not saying grab things and yank on them, I'm saying that this is firm, this is firm. So if you're in here like I was showing you where the board is in place, like so, and you need to get it out, that's where I grabbed onto here. And I very carefully worked with it until I got it out, and then got the bottom pins out, and I was able to lift it free. Now, you don't have to worry about shorting this thing out, because there's no electricity to it, and most of the caps will be discharged by the time that you get to this stage. Now, we've got some other secrets that we do with these things to kind of improve them, but I can't give away all the secrets on these. Honestly, I can't. But, like, I do give away a lot. It's just that we do some modifications to these sometimes to improve them if there's problems with them, or if a chip's getting old. We sometimes use different chips that are actually like a little bit better quality, and it took hell and high water to actually find them. But that's it. So now we can take a look at the coupling here. So you can see here, this is a giant piece of thermal mass, okay? Now you'll notice that there's no coupling. In fact, this just rests on here, and the screws themselves are what help bring this in contact with the thermal sink here, the heat sink, right? Now, that's basically it. Now, where most of the heat is occurring, which is in the switching here, in the RF switching sections, in the amplification sections, there's a lot of screws on here pulling this tight to marry it to the surface. So there's no thermal compound in between the two. There's only Kapton tape. And you also notice that some of these are actually slightly injured from manufacturing. I'm gonna put this aside now. And it looks like the Kapton tape. I wonder if I can actually lift that for a second. Let me try here. Yep, look at that. It's not even glued. It just rests on there. I'm gonna flip this over for a second because I see some contamination. That's aluminium flakes. Partially, some of it was from burning from manufacturing, and some of it was just from the screws going in and out. So we clean all this stuff before it goes out. Now, a cool thing to notice as well is this gasket. So if you take a look here at the gasket, it actually just cuts off and it terminates. That's all. See? Slight change because these things are designed to always be upright like this. So the water doesn't get into it. The water actually flows straight out. Now, another little thing to note, I'm gonna put both these circuit boards now. Can you tell the difference between the two, by the way? Which one's the 24, which is the 24HD? I gave it away earlier in the video on how to tell, so it's pretty obvious. It's like identifying a female versus a male. But anyway, let's move these back over to the workbench where they're safe, carefully. Now, something else I'd like to point out for the design on these, because they're very clever. See, the idea is to make these as cost-effective as possible. Because you guys might be like, oh, you know, why should I pay $8,000 for a radio? Not saying that's the price, I'm just giving you an example. It's because it's well built and it's purpose built. And this tech is usually handmade. This isn't something you could just blast out. So, look here. All right, hold on. I gotta be careful at how I do this now. This is all metal now. So if you look here, this is the top. See how there's this little housing here? This little frame, this little piece that's in place. So when this is married in, all the screws that actually hold this thing together are now outside of this container, the actual RF can here, right? So if water even got in, it's not going to do anything because it will just go out and around here and it'll drain out the bottom. That's why, if you look here, you will see that there's a gasket inside of this portion here because it's this chamber here that's watertight. When this goes together, water can still get in and around that, but it doesn't matter because the water seal is actually internal here. Isn't that cool?
Okay.
So that's why this thing has drains on the bottom of it. I'm gonna put this aside. Man, something smells yummy. Okay, so if we take a look now at the bottom, here's the drains. That's the water getting inside, can come out through there now, right? And then as far as the internals go, there are drains on the front as well, believe it or not, that allow water to get out. I'm gonna show you where those are. So these are your breathers right here. So there, and there. So any moisture that gets trapped inside of here will actually drain out through these tiny little spots right here because that's actually where the dishes come up. So the fiberglass isn't sealed entirely around here. And in fact, let me just see if I can easily pop this guy open. See, the silicone around here isn't great, but it's pretty good. And I don't want to peel apart this spot anyway. Now, I also wanted to show you something else. Somebody asked me about something. And you know how these things yellow? So what this will actually do is this will actually take off the yellowing. You know what? Ah, fuck it. Here we go. I'm gonna put this on the cloth, actually. We're gonna make our way around. So this will actually take the yellowing off. So if you wanted to restore your radio, which now I'm gonna have to commit to this, by the way, you can just simply hit it with some acetone. Acetone is cool stuff. There we go. Just don't breathe it in, it's not good for you.
Don't breathe this.
It like grips it too, eh? Yeah, it takes it all off, see? It's actually taking a layer off, essentially, that's what it's doing. Because what it is actually is there's actually an enamel coating. There's a urethane or an acrylic that's actually sprayed over top of the finished fiberglass to give it a nice surface, to basically give it a good treatment, right? That's actually what breaks down. Because the fiberglass plating itself, now that we're getting into chemistry, is literally just a great big fiberglass sheet. And so to protect it from the elements, this is what they do. So I'm just gonna spread this around a little bit. I'm gonna do this in stages because I don't wanna have to really fucking commit to this today. But now I'm having fun. This is kind of like playing in a Zen garden, if you know what I mean. Yeah, it just comes right off. Neat, eh? So once I take this coating off, I can resurface it with some acrylic enamel. There we go. Oh yeah, look at that.
Wow.
You now see the difference. So now you guys know a trick. Is that you can actually take acetone and you can use it to remove the yellowing on plastics or fiberglass products. See how little I'm using, by the way? It may look like I'm using a lot, but it's only because I've got a little teeny tiny hole here. Looks like brand new, doesn't it? This is very satisfying. I'm gonna do the logo. I might be able to take it off actually, it'd be kind of funny. And by the way, if you're wondering if this is just some random customers, no, this is actually one of my regular guys. And I know that they wouldn't care that I'm doing this to their equipment, by the way. Not that I'm wrecking it, but look at that, it didn't hurt the logo at all. Perfect. Let's rotate a little bit. Wow, that really does come out nice, doesn't it? And of course, you can see the paint job coming off on here now. I'm gonna have to grab another bottle of this. Actually, maybe I'm using a little bit more than I thought. This is a lot of fun though.
I like this. This is cute.
I could spend all day cleaning this. Like it just wipes off with the, look at that, you can actually see the yellow come off. Isn't that neat?
That's neat.
I'll show you the bottle of the stuff that we can use to resurface this. I'll show that to you in a minute, after I'm done having fun playing here. I mean, realistically, it shouldn't matter unless you've got a client that's being very particular about how things are, you know? So if you've got like a hotel that's like, oh, the radio's yellow on it. Well, honestly, in that case, I'd be like, go pound sand. So now, be very careful when you're doing this too as well, I should warn you. Because if you let it sit for too long, you can eat right through the top of this thing. That already looks amazing. You know what? Actually, is this fiberglass or is this acrylic? Now I'm questioning that. Might actually be a acrylic plate that's on here, actually. Ah, look at that difference anyway. So now I have to commit to doing this. So I'm gonna have to go and pick up another bottle of acetone and finish cleaning this off, and then I'll do, you know what, I'll show you guys how to recoat it as well. I've got the stuff. I'm gonna go get the bottle for you, so hold on a second.
6 hours later.
So there's two that you can use. I prefer the, so there's acrylic enamel, and then there's urethane based. But the whole idea is that you want the clear one. And also, before you actually finish this, it's very, 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 very important that you make sure that it is bloody clean. Because if you try to coat this thing and it is not extremely clean, what'll happen is that the enamel will not stick. And then you're gonna end up with a, well, it's gonna peel and it's gonna look like hell. But you wanna use something that says UV stabilized on it. Non-yellowing, UV resistant protective top coat. So you would just spray this down with it. So I'm gonna put all this hardware aside now. Now the reason why the acetone works is because it's literally attacking the surface of that. So please remember that. There we go. So I'm gonna put this over here now. There we go. And I'm going to put the heatsink back, and I'm gonna put the cover back on here, and I'm gonna put this in its own Ziploc bag. There we go. So we got these bags here, we got this bag here. Now I need to grab a big Ziploc bag. There we go, guys. So that's the teardown part. So now we'll take a closer look at the radio in a minute. I'm going to empty my memory card because I don't know how I managed to fill it.